Today we'll be working on lesson 513, solving exponential inequalities and logarithmic inequalities. The first one we're going to start with is exponential inequalities. So let's look at our first example. 8 to the power 2x minus 1 is less than or equal to 15, and you need to find the x values that would make this inequality possible. To do that, first of all, think of it as an equation and solve it as an equation. Remember, when we're solving an exponential equation, we have to change it to log form. Now, remember that the 8 is the base, so it becomes a subscript. The argument is 15, so it goes inside the log, and the answer of the log is going to be my exponent. So log of 15 base 8 is equal to 2x minus 1. Now what you need to do is you need to isolate the x by adding 1 to both sides. So log 15 base 8 plus 1 is equal to 2x. Then you still need to divide everything by 2 to isolate your x. In this case, x is equal to whatever log 15 base 8 plus 1 divided by 2 is equal. So let's go ahead and find that. So log 15 base 8, you can go to math, up twice to get to log base. You put 8 for the base and 15 for the argument. You find the answer, you add 1 to it, find the answer, and then divide by 2. In this case, x is going to be 1.151. Always round to the nearest third decimal unless you're prompted otherwise. And that would be my x value. But remember that this is an inequality, so we have to write the solution that we just got in an inequality form. So if you look back at your inequality, we have the base to the power 2x minus 1 is less than or equal to 15. So the x is on the left side, so I'm going to keep x on the left side. Then you have less than or equal, so I'm going to put less than or equal, and the number I just got. So basically, to write your solution, you have to follow the inequality that you have. If x on the left side, you keep x on the left side, less than or equal, you keep less than or equal, and then the answer you got. And especially that x, as you can see, is 2x. So it's a positive. It has a positive coefficient. So you follow your inequality as it is. Now, in order to decide whether this is our final solution or not, we have to ask ourselves a couple of questions. Number one, what type of asymptote does an exponential function have? If you look back at graphing, you're going to remember that it has a horizontal asymptote. And usually a horizontal asymptote is only affecting the y. It does not affect my x. So there are no special considerations to take. And then my final solution is going to be x less than or equal to 1.151. The only reason I would change my solution if I have a vertical asymptote, because the vertical asymptote will affect my x values. So that would be my final solution. Let's go ahead and try a different example. Again, the first step in order to solve an inequality, an exponential inequality, is to take it as an equation first and solve it. 18 is greater than 3 to the power 2x plus 3. To solve this, again, take it as an equation. That's going to be my first step. Again, log base 3 of my argument 18 is equal to my exponent. You subtract 3 from both sides, so log base 3 of 18 minus 3 is equal to 2x. Divide everything by 2, so x is equal to whatever this number is. Let's find it. Now, another way to put this, if you don't have math log base, is that you can put log of your argument divided by log of your base. So I just use the change of base formula. You find that answer, and then as you can see, it's minus 3, so subtract 3. And then divide by 2. And then x could be negative 0.1845. So the 4 becomes a 5. So 0.185. Again, this is if I'm solving an equation, but this is actually an inequality. So let's follow my inequality. Starts with a number, so the number that you just got. greater than, and as you can see, x is on the right side, so keep x on the right side. So in order to write your equation or your solution, you have to follow your inequality. You can write it as such, which means that x is less than this number, or you can just write x is less than this number if you feel more comfortable writing it this way. So both of these are correct answers. Now again, the exponential inequality or exponential function has a horizontal asymptote, so it will not affect my x values. So these are, or this answer is going to be my final answer. X is less than negative 0.185. Okay? Now let's move on to our third example on the notes. Again, to solve this, I have to set it as an equation. Remember, change it to a log base 10 of argument 17 is equal to negative 9x. As you can see, x is a negative number. We're going to talk more about this in a minute. Now divide by a negative number. So x is equal. So as you can see, x is a negative coefficient. We'll talk about this. But now let's find this number, guys. Log of 17 base 10 is basically just log 17. So you can go to math log base and go through all of that, or you can just click on log 17 because this is the common logarithm of base 10, so you don't really have to write it down. Log 17, you find it down, divided by negative 9, and then my final answer is negative 0.13671, so 367. You round 6 up. So 0.137, that's going to be my x. Now again, let's go back to our inequality. And we have to follow our inequality to write down my final solution. Now as you can see, x is on the left side, so I'm going to keep x on the left side. Usually you follow your inequality, but you have to here pay attention because x has a negative coefficient. And every time you have a negative coefficient for x, remember you divided by a negative number, so the inequality symbol will shift, okay? And then whatever number that you got. So the only time you would shift your inequality symbol is when x has a negative coefficient, because as you see over here, we divided by a negative number. And whenever you divide or multiply by a negative number, the inequality symbol shifts. Now if you go back to the example before, the x had a positive coefficient, so you were dividing by a positive number. That's why you did not change your inequality. Again, if you go back to the previous example, same thing. X had a positive coefficient, so you were dividing by a positive number. That's why the inequality did not shift. Okay? Now, again, in exponential functions, usually they have, most of the time, all the time, they have horizontal asymptotes, so it's not going to affect my x values. This is how you can solve exponential functions. Now let's move on to logarithmic functions, or logarithmic inequalities. So this is my logarithmic inequality over here. It's the same concept. Every time you want to solve logarithmic inequality, you would take it as an equation first, solve for x, and then write your solution as an equality. Now to solve a logarithmic equation, do the change, the loop thing, change it to a log form. So 4 to the power 3 is equal to x minus 5. 4 to the power 3 is a 64, equals x minus 5. You add 5 to both sides, so 69 is equal to x. But remember that this is an inequality, so I'm going to write down my inequality and follow it. As you can see, x is on the left side, so I'm going to keep my x on the left side. I'm going to copy my inequality as it is, and then the number I just got. So x is less than 69. Okay? Now, in order to decide if this is going to be my final solution or not, I have to ask myself a couple of questions. What type of asymptote does a logarithmic function have? A logarithmic function has a vertical asymptote. So yes, there are some special considerations I should take. So the solution that I just got, which is x less than 69, could not be my final solution. I have to think that the inside of my log, which is in this case x minus 5, should always be positive. It cannot be 0, it cannot be negative. So you always take the inside of the log and you set it greater than 0. Okay? X should be greater than, if you add 5 to both sides, so x should be greater than 5. This is my special consideration. To understand this more, I'm going to graph log of x minus 5, so just to give you an idea of what I'm talking about. If you forgot logarithmic graphs, if you graph it, let me make this smaller. As you can see, my graph is going to extend up till number 5, continue down. It's not going to cross my asymptote that is at 5, and it's not going to go beyond it. So my graph is always going to be from 5 and above. 5 is not included. So there you go. This is what I just said. X should be greater than 5. X cannot be equal to 5 because your function will not touch your asymptote. X cannot be less than 5 because your graph is not going to go beyond your asymptote. So every time you have a logarithmic function or inequality, you have to take some special considerations because of the vertical asymptote over here. How do you do that? You take the argument, which is in this case x minus 5, and you have to remember that it has to be positive, which is greater than 0, and then you solve for x. So in this case, I have two inequalities. I have x greater than 5, and I have x less than 69. I got this from taking the argument greater than 0. I got this solution from actually solving the inequality. So I have two different inequalities. I need to join these two in one inequality. So you have to use the number line for logarithmic inequalities. Put the numbers in order. X has to be greater than 5. Starting from 5 with an open circle because 5 is not included. The x cannot be 0. The argument cannot be 0 because if x is 5, 5 minus 5 is a 0. Log of 0 does not exist. Remember, your function is not going to touch your asymptote, which is 5. X is greater than 5. It means 5 is not included, open circle. And greater means you go to the right. X is less than 69. Again, 69 is not included, so open circle over there. Less than, it means you have to go to the left. Now these two colors met over here. So then my answer is x can be between 5 and 69. 5 is not included, so there is no equal sign. 69 is not included there, so there is no equal sign. You can write it as such, as an inequality notation, or you can write it as an interval notation. Parentheses 5, 69. Again, you put the parentheses because the 5 is not included and the 69 is not included. So every time you're doing a logarithmic function, you have to remember that there is a special consideration. Since you have a vertical asymptote and your graph is not going to extend beyond the asymptote. So always set the argument to be greater than 0 and solve for that. Now let's try another example. Log of x minus 9 greater than 1. Solve it as an equation first. Find what x can be. Now remember, if there's no base, the base is 10. And now you have to do the loop thing to change it to an exponential form. So 10 to the power 1 equals x minus 9. So 10 equals x minus 9. Because 10 to the power 1 is 10. You add 9 to both sides. So 19 equals x, or x equals 19. Now remember that this is an inequality, so you have to change the solution that you just got into an inequality form. The x is on the left side, so I'm going to put my x on the left. I'm going to copy the inequality as it is, and I'm going to put the number I just found. X is greater than 19. That is my solution. But remember, in logarithmic functions, your graph is limited. There is a vertical asymptote stopping your graph, as you can see. It does not continue. So there's always a special consideration when it comes to logarithmic functions. How do you find the other inequality? You take your argument. What is my argument? X minus 9. And you have to remember that your argument can only be positive, which means greater than 0. solve for x by adding 9, so x is greater than 9. So this is my second inequality. Remember, there should be a number line. Put the numbers in order. X should be greater than 9, which means you start from 9 with an open circle since 9 is not included, and you go to the right. X is greater than 19, so you start at 19, open circle because 19 is not included, and also you go to the right because greater means to the right, less than means to the left. Now, the two colors met from 19 and above. It means that x can only be greater than 19, not equal because it cannot be 19. That's your inequality notation. Or you can write it as an interval notation. You can write that x can be from 19 all the way up to infinity, because as you can see that your arrow goes on forever. Now let's go ahead and try a different solution or a different question. In this, as you can see, this is a logarithmic inequality. So take it first as an equation. Do the loop thing to change it to an exponential form. Now 6 to the power 3 is 216. Now subtract 2 from both sides, so 214 equals negative x. Divide both sides by a negative. Remember, you're just dividing by a negative, so what's going to happen to the inequality? Yes, it's going to shift. We're going to talk about this when we change into inequality form. So I just found that x equals negative 214. Now, when I write down the log or the inequality, because I want to follow this to write my solution, as you can see, my x is on the left side, so I'm going to put x on the left side. Usually you would copy the inequality as it is, but the x has a negative coefficient. As you can see, to solve for x, you just divide it by a negative number. So this is when the inequality shifts. Instead of less than or equal, it becomes greater than or equal to the number that you just found. Remember, you only do that if the x is having a negative coefficient. Now, this is going to be my first solution. My second solution, you have to take the argument and say that the argument should be greater than 0. You subtract 2 from both sides, so negative x is greater than negative 2. You divide by a negative number, and remember, every time you divide by a negative number, the inequality symbol shifts, so x is less than. Negative divided by a negative is a positive, so x should be less than 2. And that's going to be my second solution. In logarithmic, you will always have 2. And you always have to put them on a number line in order. And x is greater than or equal, so negative 214 is included. And you represent that with a solid circle, filled circle. Greater than, it means you go to the right. Now 2, x is less than 2. So 2 is not included. And to the left, because less than, the 2 met over here. So your x is going to be between these two numbers. And that's your inequality notation, which is, you can represent it this way unless you are asked otherwise. Now, negative 214 is included. As you can see, there's a filled circle. So you have to represent that with an equal sign under the inequality. 2 is not included because there's an open circle, so you keep it as such. Now, if you want to show this as an interval notation, your solution can be written as from negative 214, but with a bracket, because let me erase that, with a bracket because negative 214 is included, comma 2 with a parentheses because 2 is not included. Again, this is an interval notation. And these could be two different ways to write your solution. That's everything for 513.